Hello, my name is Justin Cena, and I am presenting my project created for the Practicum course at the University of Wisconsin GIS Development Master's Program. And what I have here is an app I created in response to an identified need at my employer. I work as a GIS specialist for a water utility company, and I support planning engineers amongst other folks. And one of the engineers I support, identified a need for a solution on a place where tank health is headquartered. So I created this tank health headquarters app. What it does is it serves as a place where an engineer or any user really can come on here and quickly explore the different health parameters of tanks across the system, as well as edit them and update them based on inspection reports or rehab projects that were completed, any sort of reporting really. And we'll get into exactly how. Um, yeah, first off, I just want to make mention of the GIS and T body of knowledge principles utilized. Programming and development, it's kind of a no-brainer, of course. I think that applies to all of us in whichever sort of project we created. Cartography and visualization, I tried to implement wise cartographic decisions, the gray backdrop so as not to take away from what I used here as a color coding based on tank parameter. So you can color code the tanks based on different conditions, the age, the time since last inspection. I implemented, different zoom scales for different actions. And I have to make mention also that the reason things are so simplified, like these big square districts, is because I had to fictionalize a lot, all of the data in use here. And so everything you'll see here is actually either fictional or the reports that I use in my example I found that on the internet, and it doesn't actually relate to any of these points. Um, let's see, and then just to finish these off, data manipulation. It's going to come into play with the ability to edit the data. The format it's all stored in is a GeoJSON, which edits on the fly, which is really nice for one of my main goals here was that everything function locally on a local machine. For security reasons, so as not to pass company data into an AI on the internet. Um, and again, we'll touch on those things. And the final one here, analytics and modeling. I felt like there's actually a little bit of room for this category to expand on the book of knowledge, as there's definitely a place for using AI LLM capabilities in data manipulation, and that's exactly what I did here. So to get into the app, just right off the top, I've got this info banner on how to use it. Just like quick home button so that you can quickly zoom back to the entire system overview. Again, this is a completely fictional system, broken up into four districts identified in the legend. I showed you the color coding. It also has the ability to filter markers on the map. So say you really are trying to only look at, particular districts. Let's do, or how about tanks of certain ages? So you could say, show me tanks that are at least, 26 years old, and it's gonna bring those out for you. Additionally, it's going to change what shows up on the map on this info panel, this info pane that I have on the side. Um, this graph here is probably the biggest challenge of this entire project was getting a graph that is synchronous with the map and the selections, functions as both a bar and a pie chart, and can take the parameters, uh, can take changing parameters, uh, and still display while continuing to have the ability to honor the map selection. So say I want to only look at, I don't know, these. You can honor the map selection, and it breaks it down to only show those that you want. And then even further, say you don't want to honor the map selection, you can choose the bin that you like to say, well, which four concrete tanks are there, and it'll narrow those down for you in this drill down table. You can also select the tanks from here. It looks like District 1 has concrete tanks. Um, so you can explore the data in that regard, make these changes. Additionally, when I was given the set of parameters from the engineer that I was working with, asking like what would be most useful, they provided for me like some quick, uh, like the things they most common would they need to figure out. And so I just went ahead and pre-built those, so no inspection for at least 7 years. It brings those to the forefront. Um, Distribution of tank capacity, like it's all just all these different parameters and configurations that help our engineers understand like what are the most at-risk tanks in need of rehab investment, or which tanks are, different configurations. So let's go ahead and clear this and clear the selection. So yeah, I put in a little note here. Tank name grouping works best for small selection analysis because this exact kind of thing happens. The graph starts to look a little crazy. Um, but I liked the ability to sort of select the bin and view these from the drill down table, because what it goes to in even further is say it's like, well, this one has a really high estimated rehab cost. You can select it, and then at the top in this next pane, what you've got here is the ability to review the information. And at this point, I'll jump into a couple use cases. So first of all, like I was saying, the two primary uses of this are the ability to review the data, which we just did a bunch of. So say you needed to locate which tanks are the best candidates for uh, like a exterior rehab projects. Maybe you've got a contract for a group that can do four this year, and you need to determine which four tanks are most worthy. You can come in here, color by exterior condition for just a quick overview. You can also set a filter to only see, exterior conditions that are poor, very poor, or perhaps unknown. You can explore what's to do with those. There's a ton of gaps in this data because this isn't a solution that's existed up to this point, right? Um, and so that you can bring this information to the forefront. It's like, well, which are my two very poor tanks? You can see them over here just quickly if you want to go in. Yeah, typically a map like this, you would also have all of the pipes and valves and the complete system, but having to fictionalize everything, that would be a huge challenge. So right now we can only really see these tank points. Um, and you can tell, oh, it's the two chocolate woods tanks. And so you could select these, come over to your asset details, and you can determine that these are great candidates for a rehab project. Now, on the back end of the project, it's completed. This data still shows as this old condition, but what's important is that the user also now has the ability to update this position, these conditions and these details in two ways. For one, they can open up the table, they can read these reports manually, and they can I don't know if I explained the table, but at the bottom here, I have this table where you can search by name and you can make the selected choices be isolated or highlighted, and you can perform inline edits, and that will save to the GeoJSON in the back end. And I'll show you that right now, actually. On the back end here, we've got just to show you the kind of the layout of the app. It is a React app, and is I really wanted to use React in this project as an opportunity to really explore how React works. Um, you've got my in region one here, we've got my state hooks, and then the rest of these sort of top end regions are derived states or event handlers that do all of the different functionalities that are included in the side pane, and the symbology selections, the IDP processor I'm about to show you. Data fetching communicates with the the tank's GeoJSON here, um, which is actually what all of those tank points are. I didn't connect this to a database, like I said, I put this all into a GeoJSON. Um, what it does is every time you perform one of those inline edits or when you use the AI IDP extraction, it's automatically overriding these parameters in the GeoJSON on this backend using a Python Flask server. And let me show you the IDP process first, and I'll come back to that. So like I said, we are in the back end of a project, and now we want to upload an inspection report. Now, just a little explanation on inspection reports. You know, they come in all shapes and colors, and actually they're all pretty page shaped. But the formatting is inconsistent. And so an engineer would be responsible to read through these documents and find the data themselves and update these data sets with the current conditions, which is directly to blame as to why there are so many gaps because that's not maybe their strong suit or and they only have so much bandwidth to perform so many tasks and managing these projects is really where you want to keep them. And so I will say that this one I found on the internet is pretty short compared to the ones I see at my work. They're like 60 plus pages, where this is only 11. So I don't know if this is a sample one or a shortened one. I'm not sure. But typically they're much larger, and they just kind of break down the conditions found during the inspection or on the back end of a rehab. Now, what I built into this app is kind of the removal of that manual document scrubbing. So they click the upload inspection report, drop it into here. Now, like I said, everything's fictional. There is no Chocolate Woods #2. We're gonna just use this Wiggins tank inspection report that I was just showing you. Now it's gonna have mismatches top to bottom because they're not the same tanks. But you'll get to see how this process is working. On the back end in the console, you'll see that it's actually running this IDP process bypassing Google Gemini, uh, the document, and this prompt. So that's what's good too is if you want to adjust the parameters or tweak the prompt because something's not quite functioning how you would like, you can come in here and do that. You can just adjust this prompt so that it does exactly what you're looking for, and that will present you with what the LLM found as the values for these different parameters. So you can see like the found values, and more importantly, to keep the human in the loop component here, to not just blindly trust that AI is doing a good job. It tells you where in the document you can find the information. And I've done enough of these and tested them now that I have yet to find one incorrect. It's actually just not going to fill anything out if it doesn't directly find it, and that's all part of the prompt. It also is going to report individual notes that were made on the report as well. And so you can either choose to accept or deny and say like I didn't actually see this anywhere. That looks like a mistake. You can choose to just not accept it if you want. But at the end, you can hit commit updates, and you saw the data change over here on the side with this new noted failures, new information to consider. Um, you can say that this is now up to date. The information on Chocolate Woods, oh, the name changed as well accidentally because it's not the same tank. But you see the process here. It also updated in the table, and the GeoJSON on the back end also updated. And yeah, so that is the process for you know this would be a tool for those folks, those engineers who are responsible for maintaining a water tank at utilities, to keep their tank health data current, to plan projects and make wise tank rehab investment decisions. Thank you very much for listening.